Hey everyone, today I'm going to be working on an iPhone 6 Plus, board only that was sent here as no power after a fall. I have no idea what I'm getting into. I actually thought it was a customer that had sent one device, but he had sent two. One is a traditional classic Touch IC failure, which we're not going to do a video on that today, but the other one is no power after a fall. So let's see if we are getting into something here that is going to troll me, or if we are getting into something here that I'm going to be able to fix in front of a camera and make myself look super intelligent. So, first thing I'm going to do, let's check its temperature. We still got tweezers hooked up. I've got the supply limited to 2 amps, and we are going to get some longer leads on my probes here. So let's see what we get. I'm going to hook the supply right here to our terminals, and we get 800 milliamps of current without powering this thing on. And okay, so 800 milliamps of current. We don't know what we're up against. It fell. Now it don't turn on. 800 milliamps of current. Oh, what is this? This sounds so familiar. What is this? I had one here just not too long ago. It's been a month or so. 800 milliamps. But that was after button press. 800 milliamps after button press. So let's go ahead. I'm going to peel the sticker off this thing. It's obviously been off before. Most of the stuff that comes here is prior repair attempts. I mean, seriously, who is going to mail their stuff off to get it repaired if they can have it fixed locally? Nobody. And that's why almost all of them are prior repair attempts, because everybody tries to fix them and then they get sent here. So let's switch you over to the microscope, and we're going to have a good look at this thing and see if we can't see anything with our eyes. I do notice more oozy. Are we in focus? A little more oozy, fluxy than what I'm comfortable with seeing. And we're just giving this thing a good visual evaluation to find out, try to get somewhat of a history on this thing. I see some really weird, like flexy things oozing here and there, almost consistent with what you would see on a board that's been heated. That's been heated with hot air. Look at this pattern there on Mason. Like, okay. And we got a little Q-tip fuzz here. And I'm not used to seeing the big chunk of stuff missing there. Okay, other side of the board. The board's definitely had heat, a lot of heat used on it. So you can tell this, like, you can see where the flux has became liquidous and ran, and this thing has been hot. Really hot. Alright, let's see if anybody is detached. We can just go along here. These all look pretty good. These look good. These guys look good. 800 milliamps of current. Maybe it's had Touch IC repair done on it before. It may just be a prior Touch IC repair. It could be. Let's take a couple of measurements. Let's check and see what sort of resistance we get to ground on our VCC main line, and also what sort of resistance we get to ground on the battery line. Okay, so you now have what I see. Take me a minute to get used to how I'm going to arrange my bench here. So I'm going to be putting one probe on ground, and I'm going to be putting my other probe on VCC main. I'm doing my measurements in resistance mode, which we get a flat 0 ohms on VCC main. I'm doing my measurements in resistance mode because that's the way I'm used to doing it. And I've actually never done a diode mode measurement because I've been using the same old junky voltmeter for my entire life, and now I got this new one that will actually do diode mode measurements. But it seems to me like it's just going to be another way of looking at the exact same equation. How much of a connection is here or there? So, okay, so we definitely have a short on VCC main. So we're going to blast it with a little current and see if this thing will give me a clue as to which side of the board that it's on. Since this customer did not mention anything about the prior Touch IC repair attempt, it makes me think that they either didn't know about it or it's been working fine since then and this thing quit after a fall. So what I'm going to do here, I'm going to take my ground probe here and I'm going to clamp it on ground. And I'm going to take my other probe and I'm going to use it to probe. You can do this either way. You could clamp it on to VCC main and then use the ground side to probe. You can actually do this either way. We don't care which direction, really don't care which side of this is getting clamped on. We do care about which direction the electricity is flowing though. Oh my god, I almost said something horrible. Alright, and then I'm going to be using the other end of this to poke around. So for that, I'm going to give you Microscope, and I'll probably make it so that you can see current from that view over there. And what is our current set to? Right now we're limited to 2 amps. We are going to go ahead and give this thing a bit more. We're going to let it run up to 3 amps, and to test that I was just touching shield to shield. So, okay, so we're going to deliver 3 amps of current right here into this VCC main cap. And we get 800 milliamps. I'm waiting for heat. Anywhere, I'm starting to feel heat. There is heat building, but I can't tell where it's at. There's definitely heat building right there, somewhere I think around the audio codec here, and let's see what we can do. I still have not eaten lunch today. It's almost 2 o'clock. If I eat lunch, then something's going to not get fixed. Alright, we're putting current back through this thing. Still, at 800 milliamps, it's really difficult to tell who's getting hot. Unless maybe it's one of those shorties down in there. Could also be directly on the other side of the board and could be under the CPU. Now, since I don't see anything obviously discolored here, except for possibly one of those guys there. I don't know which line they're on, but I'm not going to track them down. We're going to go ahead and pop the shield off of this thing. Gosh, I don't know which order to do this in because I don't always do this repair on camera. So to take the shield off, we're going to remove this little bit of glue. I don't see any long screw damage, so that little bit of glue there is gone, out of focus, but it's gone. And then I always anchor the board down to the table. Yeah, it's lunchtime for sure. You can hear it in my voice. I'm ready. I am ready for a break. All right, so let's go ahead and pop the shield off of this thing and see what we can see with our eyes. I've never actually burnt a trace inside of a board before, but I do wonder how long these things will sit here and take the current. Because, you know, it's not designed for 5 amps of current. It's not. And for all of you telling me that it's not the current that makes the heat, it's the current plus the voltage. Dude, do you think I would be sitting here fixing electronics if I didn't understand Ohm's law? I absolutely do. So I agree, current multiplied by voltage, and here's your total energy, and this board dissipates heat this fast, and this is why you're not getting a buildup of heat. There's not enough energy going in. I understand that. I mean, yes, I do understand that. However, keep in mind that you will not get heat without current. It is the current that makes the heat. So, let's proceed with this repair, and I will continue to use current to find my heat. I mean, I'll use current to create heat and find my short. Shield is removed. I'll slide this back in reach of my microscope. I normally wouldn't move it a second time, but I'm recording a video. And let's have a look under the shield. I really don't see anything. We're looking for discolored components. We're looking for anything, you know, a coil that's roached, anything that might give me a clue as to what's shorted. And I don't see anything blatantly obvious on this side of the board. So let's switch over to ZXW tool. I know roundabout where my heat was coming from. I still don't know exactly which side of the board it was on. Alright, so here's VCC main. Here is our options as to what it could be. We know we had a lot of heat here. It could be U5301. In fact, I think I've seen that melt off, like dry off really fast. Right now I'm killing time waiting on this board to cool down. We're going to leave the shield off of this one for a minute. Okay, so we're going to come back in now. And let's just do exactly what I was doing before. I'm going to hook my ground up to the board. I'm going to be over so I don't have any tension. I'm going to add some alcohol to the board. I'm also going to make sure my supply is putting out a nice firm 4.2 volts. We're going to go to a full charge LiPo because I want to, you know, it's not producing a absolute full short. Wait a minute. I measured 0 ohms across VCC main, yet I'm getting 800 milliamps of current, which means we don't actually have 0 ohms. Once current is applied to this short, it's letting up, which means it's turning into a heating element, and we can expect it to get hot. We don't want 4.3, you piece of crap. I want 4.2. Let's go 4.12. Okay, wet this all down, and let's apply 4.12 volts. Alright. I think it is very clear that this dude here is getting hot enough to blister my fingers. I mean, that sucker is getting hot. Let's go ahead and pay attention to that component only. It's U5301 RF. Okay, we're going to wet the top of it, and let's see if we can get the top of it to bubble. Well, you know, seems to be clearing off around it a little faster. Still holding 860 milliamps of current. Well, whatever is shorted must be shorted nearby. Is it up under the shield? I mean, I can't see anything getting discolored. Let's check the top of the board. Okay, let's find a spot to put in VCC main on top. And we're going to go in, I'm going to put VCC main right in here next to the right side backlight driver, those two caps that face it the closest. So we can grab either one of those and pump in VCC main there. Ouch! Damn, why do I always do that? Ah! Ow! No heat. My ass. Alright, so I got the shit burned out of me down here on this corner of the board. Alright. So let's go ahead and anchor this thing to the board here. And give you full out microscope. In focus preferably. And let's see if we can tell what burned me. On screen capture, we've got a handful of things here on VCC main. All over on this side, you know, up into the middle. But I feel like I got burnt down here. What's, you know, You know what? Let's just let the alcohol tell the tale. Let's put some alcohol in this dude. Try to get as much of that in view as I can. That's my limit. I was thinking I'm at 0.5x now. I was thinking about going like more than that, like minus 75, or can you even do that? I don't know. All right, so let's soak it up. And let's put current in up here by the right side backlight driver, and oh, whoa. What melted off here? Was it Chestnut? It was Chestnut, wasn't it? Alright, so let's have one more good look at that thing and see if I can't tell what is producing that load. And that would be, let's see, U1501, or was it U1601? Ugh. Like I said, it's one of those things where I know the exact ID or whatever technical term it is until I try to say it in front of a camera, and then I forget. I become stupid. Alright, so let's put power into VCC main again, and bam! Wow, look at Chestnut just goes smoking off of there. So is it Chestnut itself, or is it something outside of Chestnut? I don't think there is anything that we could do to Chestnut outside of it that would cause that sort of a short. So let's have a look at the schematics here. Drag my window the other way since I screwed up my screen capture. Oh, and I got a note here too. Yeah. On my iPhone 6 schematic, Paulo Arnaud. I'm probably not saying your name right, but man, thank you. You emailed me this schematic. You said this will clean up your channel or something because of all the Chinese writing, which I had sat down and made it a point to remove all that Chinese writing. That's why I have a file named Remove Branding, but I think I only made it to like page 30 or something. I don't know. I didn't make it very far. So that is much appreciated. All right, we have the schematic open up here. We are going to search for Chestnut and find Chestnut IC and look and see what all that's wired to. You know, let's just confirm it is U1501 here on our schematic. And over here on ZXW, it is also U1501 that's getting hotter than a firecracker. That's our display power management IC. And if we look at U1501 here, let me see if I can get all this on the screen. My sizes are all... Wait. I'm capturing it a complete different resolution now. Oh, I wonder what that's going to do to my videos. This was going to be a good video, but I might have this really screwed up. Anyways, U1501, that is our display power management IC. You can see we have VCC main coming into it. It is VCC main that is shorted. We're not getting like a full short. We're getting 800 milliamps through it. Yet, whenever I check it, yeah, and I probably shouldn't be torturing it with all that current, because what do you want to bet? There's a possibility here that it's not that IC. Like, I don't know what all these pins do. I don't know when we apply VCC main here, if any of this other stuff over here is hot. I'm going to assume that none of the LDOs are. Can we have anything else here shorted to ground and give us the same... and put all the current through the IC. Before I pull that IC off the board, let's check it. Let's check C1502. Let's check this PP6V0 LCM boost line. So we're going to check, I already forgot, C1502, right? Oh, what a day. Okay, that is on the back of the board. And it is on this 6 volt line. So let's get onto the back of the board here, and we're going to check. Oops. We're going to check continuity to ground across that line. I'm still getting used to this meter turning itself off. So what I'm going to do is I'm going to be checking here on this board. And I'm really having a hard time keeping my windows straight here today since I've rearranged stuff. I gotta fix it. Alright. I actually did a handful of videos here, and I think they're all going to be screwed up, but at least the best of it will be there. Alright, so here in the bottom right hand corner of the screen you see this board. I'm going to check for continuity. Let's see, we got 3 caps there, and it's the 2 bottom 2, the inward facing sides are our 6-volt lines. So we are going to check continuity there to ground, and I get 3.5 million ohms, which, let's try that again with this on-screen thing that upset my whole peaceful harmony that I had going on with all my scenes and frame sizes. Yeah, so there we are. We're actually at 700 million mega ohms. So I'm going to say that we don't have a short there. And then what other lines do we have here to be concerned about? Like, I don't want to pull that IC if it's not the IC. So we just check both of these lines. Now I'm reasonably confident these 5.7 volt lines, I don't think they come to life. I don't think any of these LDOs come to life without that chip getting powered on. So let's check this 5V7 Sage AVDN line, C1504. Let's find C1504. And it is actually up here. It's the first horizontal cap on top. So let's go after C1504. So we're going to go to ground on one side, and the other side we're going to put on the active line. And I get 45,000 ohms. And it was covering up my open broadcaster, so I'm going to do it one more time and make sure that showed up right. That's at, oh wait, am I on the right one? Well, it was 45,000 ohms, but now it's almost 8 meg, and I think it's because we probably got caps charging. I'm going to reverse my test leads, and I'm going to do that once more, and we should get something a little more... nothing. Yeah, so we got 45,000 ohms. After I switched leads, put them on there, which drained caps, and then switched them back, and then we got our 45K again. But I bet you, if I leave this on here long enough and just keep it on there, it's going to be all weird. See, we got almost 7 million ohms, but then if I reverse polarities here, we're going to go back to that 0L and then test it again, and we'll get our 45,000 ohms. And this is from capacitance, charging, and you know what else. Well, gosh, who knows what all this is from. It's from a lot of stuff. Needless to say, we have not found our short yet. So back over to my schematic, and I've checked everything but these 5V7 lines. Yeah, I don't know, man. I guess it could be. Could be any one of these any one of these lines that somewhere out there they've got a path to ground. But I'm thinking it's actually the IC. Let's see what's going on here at L1519. Okay, so that is this big inductor here, right by the IC. It comes in here as VCC main, and it goes back out to this LXP line. So you know, this reminds me of the SW line on the 6S backlight drivers. They've got that SW pin. That's what that reminds me of. But everything here points to a short on inside of the Chestnut IC. It really does. I don't want to leave any stone unturned before I put hot air on this board to remove Chestnut. I mean, I want to make sure that I am after the correct component. So I've checked this line for a short to ground. Here, I've checked this stage line for a short to ground. I have not checked these LDOs for shorts to ground, and I know that they go out there somewhere where they could actually have a short. We got C1541, 1569, and C1577. We can also check those right out at the connector. So let's go for, you know what? I'm sitting here looking at an iPhone 6 schematic, but I'm working on a 6 Plus board. Let's correct that first. Let's get an iPhone 6 board open. Middle click. You are not my friend. And I don't think there's anything different about Chestnut. We're probably okay with everything we just did. I just want to make sure there's not any extra paths to ground here that I'm not seeing. Alright, I don't see any extra paths to ground, and we've covered this line and this line. We have not covered these lines, so let's check C1541. Okay, and it is on the back of the board. Wedged down in I am on a 6 Plus board now, right? Okay, so we got our little trailer park, and it's wedged down right in the butt crack of the Broadcom IC and the codec IC. And I see this meter is now giving me a low battery warning. Okay, it did not make it a day. Where did I say that was at? Alright, so we're going to put one probe on ground and the other probe on this side of this thing. 245,000 ohms. And I think I still have that on the screen for you. Yes, okay. So we know it's not that line. We're going to check C1569. And honestly, I don't think any of these can provide a short to ground without this IC being powered on. Okay, C1569 is also right in here next to the codec IC. So let's get in there and we're going to check it for a short to ground. I bet you're not seeing my readings. I bet it's staying at 0L. I can't see that corner of my screen. Yeah, the low battery alarm cut off the RS-232. And then it shut off on me. Alright, so this thing is really going to like batteries. You make it through my video. I need to finish my video. Nope, it's going... Alright, I am back here with this thing. Let's hit RS-232. Should have it on the screen. Come on, give me 0. What did I do? Oh, I put the battery in it and forgot to connect the serial cable. Alright, RS-232, it should just pick up because we didn't actually... Yeah, there we go, 0 ohms. Okay, let's continue troubleshooting this board. What were we checking? We were checking a cap. I don't remember what line it was on, but let's go check it again. This side of this cap gives us 240 mega ohms, right? Let's set this back to auto. I always forget to change this. It's a little bit taxing to maintain, but we'll see what kind of tricks I can come up with. Alright, so we're set on resistance mode and we're on auto, and we get 200,000 ohms, and then nobody's shorted here. Okay, so that covers the next one in line. And let's go ahead and check C1577, which once again, I'm pretty certain that there's no way any of these can give us a path to ground without that chip being on. And C1577 is actually way up here. And we can check these two up here that are side by side. We're going to put one probe on ground. And the other probe on the live side of those components. And we get 325,000 ohms. So nothing there is shorted to ground. I think we've pretty well narrowed this down to the Chestnut IC itself. So let's go ahead and remove it from the board very carefully. Let's see what happens. Microscope only. And we're going to start warming this thing up with hot air. And I'm also going to do a little bit of picking around it here. And try to make sure none of this glue causes us any issues, because it sure feels awfully solid. Ah, I hate this glue. I have to use some better tape. Yes, I know. Board stand, $7 or whatever. I will eventually spend the money. And I'm also going to buy a decent blue mat that I can solder on too. Alright, let's see if we can finagle, coerced, speak gently to, talk this thing into getting this piece of crap off the board. Because we are going to find out that it's shorted. And then my dot on that, because we got to put one back in its place, it's going to go over here. On that side. Alright, so let's see what we got here in the way of glue. I shouldn't have put my tape across the CPU, because then the thermal compound acts as lubricant, and then my board slides around. Hey, you can go ahead and laugh. I'm sitting here making money doing this all day long, and I love it. Yeah, I know. Here he's bragging about making money, but he won't buy the right tools. I get it. Trust me, I understand. I understand. And see, we're doing all of this and putting complete faith in the last guy that worked on the touch ICs. Like, we don't have a clue what this last guy did. Seriously. And I'm going to try to get this in focus for you the best that I can, but it's really difficult for me to see it. Just know that I'm carving on the Chestnut IC here, because I think it's faulty. I think it was a pile of garbage, and I want it off of this board, and I want it to come off this board peacefully and not damage everything else around it while I do it. Okay, we're going to get some flux in here. And I'm going to start nudging at this thing a little bit until I think that it's free. And a lot of times I can get my blade right under the corner of it here, and I can actually feel when the balls start to melt. I can see it moving. I'm going to back off because I actually see solder squeezing over here on this inductor. I hope this is all showing really good, because this is sort of a good show. I'm right on the edge of fixing or killing. So we're going to get it moving again. Right there. I'm going to position my blade under it and pop. There we go. So I overheated a little bit here as well. I'm not sure where this ball came from, but we're going to have to investigate that. Overall, that was actually a little bit dirty. That's alright. Sometimes we like it dirty. Okay, so let's pick all this goop out of here. may be about to mess up here and raise a pad, being careless. And let's go ahead and take care of these pins. Let's do this with an iron. That top right pad there, I may have just hosed that up, being in a hurry. Let's get rid of all these balls so my tools don't have anything to catch on. Cause my life to be a living hell. I'm starting to think I might have cracked the IC next to this one, especially the way I'm raking it with tweezers. Okay, we're going to get this cleaned up here, and then I'm going to have a look at that IC next to it and see if I've caused myself extra work. I'd say there's a pretty good chance I caused myself extra work. I like putting the alcohol on hot. That was a little hotter than I normally would, but it makes for a really, really, really clean result when you put that stuff on there that hot. Let's shut the hot air off, and let's get in a little closer to this pad that I think I damaged, which looks like it comes right out of a damn via. That would be lovely. No, that's going to be okay. Let's leave that alone. If I sit here and dig at that and pick at it, you know, then it's not going to be okay. And I'm going to have to put a jumper from this little tiny via over here to that pad. Unless it's ground, but don't look like ground. Okay. I'm not wanting to make this look clean. I'm getting rid of any high spots. You know, any adhesive here or there that might prevent me from setting an IC on this board straight. Okay, now we're going to unbuckle it, and I'm going to have a look under the IC that I disrupted with my heat. And for that, we're going to need to raise up the microscope. Okay. Yeah, and there is actually plenty of underfill under that component, and that is likely to have caused us some problems. Let's get rid of this one visible ball here. There we go. It's out of there. And let's see what we're up against. There's a pretty good chance I'm going to have to reball that or replace it. And see, I nicked the corner of it. That's no, 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 no. Alright, so here's how we're going to figure out what that is. To figure out what that is, we're going to look at U1602. I'm betting like a really big chip for something goofy, like strobe or something. U1602. So on our schematic, we're going to search down U1602, and we get strobe driver. Strobe driver. Lucky guess? No, no, not really. Reassurance? Yes. One more look at that strobe driver. You know, there's a chance that my heat didn't completely disrupt it, and me taking it off and putting it back on just because would be absolutely foolish. I don't see balls pushing out anywhere else. It's possible that that strobe driver might work absolutely fine. So we're going to put our trust in it. Let's grab us a, well no, before we grab us a Chestnut IC, let's check resistance to ground on VCC main. So to do that, we can pick any spot. Let's just move right in and check our resistance to ground right here. And we are getting a very reasonable 50,000 ohms. That's not, we're not causing any harm there. So let's get us a Chestnut IC and see if we can't get this phone to boot. Here's our old Chestnut IC. Let's throw this under the microscope. Does it look like it's been baked? No. Doesn't look too out of the ordinary. Freaking glue all under it. That's annoying. Huh. Alright, so let's grab a Chestnut IC from right here. This is an iPhone 6 board. It is a very happy donor. It revives many phones. Now I do have a ton of Chestnut ICs on the way because I happen to know I think this is the very last one in the shop. I am out of options, and I have ordered these from Microscope.com. They always ship what it's supposed to be. I mean, it's always new stuff when you order it. Rather than ordering something that's supposed to be new and it just looks like reballed bullshit. Like, I don't care if you ship it to me and it's reballed. That's not a big deal. But whenever it's dirty reballed, like hunks of fuzz all over it and chips that are all cracked up into bits and then reballed, like with chip chunks missing out of them, that's bullshit. And Microsolderingsupply.com has never did anything like that. It's always been usable stuff. Alright, let's give this thing the gift of new balls. We're going to add a little bit of flux to it. See if I can do this without busting it. I got the wrong tip on here. We got curvy tip. We'll use curvy tip. Curvy tip will do this. Come on, beep. Beep. I've actually done that before and then the dang thing been off. That makes you feel really intelligent when that happens. Alright, we're not going to clean this up any more than I have to. That's a little grungy, but we're going to use it. So let's get the flux off of here because I don't like to have any barrier between my solder paste and the pads. I'm going to be honest, that looks like total crap. Look at all the pits and garbage there. Let's dry this up and do this again. Okay, and then let's get rid of this one little nick up here. Is it a nick in the chip? Or is it debris? It's debris. I thought it would be. I'm gonna put a little flux on here. Like, I don't want my crappy reball job to be the reason why this don't work. And I will admit, this Chestnut IC is not a known good Chestnut IC like I'm used to dealing with whenever I'm replacing Chestnut. So the entire repair could be flawed. We still got that strobe driver to deal with. Why do we need a chip that big to light up a freaking LED? Seriously. Alright, I have not used, I pulled out a new stencil just the other day, and I don't think I've reballed a Chestnut IC on this one. Wait. Haha, yeah I have. It's got fuzz all over it too. Let's see if I can't get rid of the fuzz. Right after me bitching about reballed chips having fuzz all stuck in them. Come on, where's it at? No power after a fall. And this is why People wind up quoting such broad price ranges. Alright, we're going to use it. We do have a little flake of debris down in that hole, but sometimes we like debris in our holes. I think that'll be fine. I have a perfectly equal amount of little tiny solder beads in each hole. There's not one that has a single bead more than the other. And we're going to start warming this up. I'm going to watch the puddle to my right. Can you see that on the screen just barely? I'm going to watch that puddle melt first. Over there, way over there, there we go. And then I'm backing off because I don't want these little beads to go crazy. So warm it up slow. And I always try to heat the right column first and then roll it to the left. Oh, look at that one that popped down in place right at the last minute. Let's heat this again. Okay, let them solidify. Wow, they're way too hot. There we go. And then let's see if we can't get this to drop out on the table with its nice symmetrical balls. Alright. Ching, ching. One's a little bigger, but you know what? A pad on the board here or there might be a little bigger, so let's not worry about that too much. Let's swing right on over here to the board that's going to be receiving these balls. And on this phone, I'm going to hope that I have a passcode because I really need to test the strobe. Alright, now the site looks like complete, utter crap. And I'm going to clean that up a little more before I drop a chip on there. But I'm not going to do any more scratching with an iron. I'm not going to do any more heating. That's going to be it. I've got a clear shot to every pad. Except maybe down here in this corner here. Yeah, I see some goop I left. You know, I want the chip to be able to move around and settle itself into position, and I left a lot of goop down there. So let me see if I can cut it. And I really should heat this up and then do it that way. So let's not nitpick on that anymore, or I'm going to wind up chipping something else around it. Oh, you couldn't even see it because I was out of view. I'll wind up making this worse. It's not that bad. It will accept this chip. So I'm going to go ahead and put this on here. I'm doing a really, really bad job at recording this one, so I hope I can still publish this video. I'm pretty sure I didn't do... I mean, I'm pretty sure I'm going to fix the phone, so that must say something. Whether or not I fixed it the way everybody likes it, I don't know. But that don't really matter as long as the customer likes it. Alright, and the dot on this IC is going to go that way. I scratched a little mark here on this cap. And I got a little scratch on that cap right there. I zoomed all the way. Ah. I put a scratch on this cap over here to show right here. Which way to orient Chestnut. So now we know we have leaded solder on the bottom of this IC. It will melt a lot easier than everything else around it, which takes some of the stress off. And we got to pay a little attention here down in between here. I see something shining down there. We want to make sure that that's not anything that's not supposed to be there. You gotta watch out for balls squeezing out, man. Those things will squeeze out and touch things together that are never meant to touch. Alright, I think I did a wonderful job at accidentally lining that up. I'm going to start heating the whole entire board up. Try to make sure our flux doesn't move our IC around. Now, our brand new reballed IC right here, it's going to settle into place before anything else because it has a lower melting point by quite a bit. Starting to move. There we go. It is in place. Boom. Little bump. Okay, that's in place, and I did it without melting anything else around it while the board is still hot. Let's move in and look and see what I did here between these two gizmos. Let's see, which one am I on? Am I on the wrong blade? I think I'm using the wrong knife today. Am I out of knives? Let's see if the surgical scalpel's any better. I think it was just a tiny little flake of something. I don't see anything down there. Let's not nitpick on it. Let's stop right there. That looks free and clear. That's what matters. And the little chip I put in that IC, actually in all of those ICs, don't pay attention to that. That wasn't me. That was somebody else. That was the last shop that worked on it. It was their fault. Do we have a short to ground on VCC main? I'm almost scared to check, because sometimes you'll think that you got the right IC and then you don't. Like sometimes you'll think you got it, like that chip's the one getting hot, but then it turns out it was something else underneath that chip, and that chip was just stuck sinking all the current. So I think in this case we're going to have had a shorted Chestnut IC, but let's find out. So we are going to turn on RS-232 and switch this thing back to auto. And we're going to move over here and we're going to do a resistance mode measurement to ground on VCC main. And we get like 50,000 ohms. So our short to ground on VCC main has been relieved. We have now gotten rid of our entire load. And you know I didn't just about drop tweezers on this PCB. Alright, so let's slip it into a housing. I'm going to stick it right in there. And we're going to hook up a screen. Go ahead and hook up our buttons since they're there, without damaging any more connectors or damaging anything else. This one hopefully is not getting any connectors. And we are going to power this from the DC supply so that we can get a nice pulse or heartbeat. Let's just get some vitals going on here so that we're not totally blind. When you got an iPhone that won't power on, like there's very little to go by, or like if it, you know, you're very limited with what you get to see on the screen. There's just not much there. So by having the thing actually run, and that means run, hooking your power directly to the battery line, I don't mean through the charge port, but to the battery line, you can actually see what sort of power that the thing is drawing. So let's hook up our 6 Plus. We're set at 4 volts. I don't know what the amps is. Let's just max them out. If it's anything crazy, I'll pop it off there right off the bat. Alright, so oh, is my plug finally done? This little plug's been due to not work anymore. Nope, it still went down. Alright, so we're 4.2 volts, 0 amps. That is a marvelous sign. That means we don't have the same short. And we are going to hold down the power button. And we get, yes! So, the Chestnut IC was shorted to ground. And I have to say, I've been through a lot of shorts to ground, and that's the first time I've ever had the actual Chestnut IC be internally shorted to ground. Now, somewhere out there, there's probably somebody laughing, going, it happens all the time, dude. But I've never had it happen. Golly, man, I've fixed piles of phones, and I've never ran into a Chestnut IC shorted to ground. Hopefully my cameras will record, and that way I can share my experience with the world with my microphone unplugged. You know how many times I've done that, recorded the whole entire video, and realized it didn't hit, like, nobody. Alright, so we're going to let this thing start up. I'm not going to move it because I don't want my battery connection to pop off of there and screw everything up. But the next thing I'm going to do is check touch functionality. Now keep in mind, this is an iPhone 6 Plus. So being that this is an iPhone 6 Plus, there's a really high probability that after going through all of this that it's going to have touch IC failure. Now, even if it's a 6 Plus that didn't have any, it's going to need a battery. It don't like my supply. Even if it's a 6 Plus that didn't have any symptoms of touch IC failure before, there is a very significant possibility that it's going to have issues with it. Now, since I don't know what the condition of their battery is. However, with most VCC main shorts, the battery, like some sort of breaker inside of the battery, has been tripped. And what I did, you didn't see me. I just plugged in their battery. There's been some sort of a breaker inside of the battery that gets tripped, and once you relieve the short and you connect the charger to it, first it's going to act like it's got a dead battery. Nope, this one's going to pop right up. But usually you'll get like a dead battery. Which screen did I grab? Did I grab the one that's bad, or does this thing have visible Mason failure already? Can you see the lines in it? You probably can't. They're really, really faint. I got vertical lines down the right-hand column. I think I actually... Why do I keep throwing that screen back up there? That's my screen. Let's see if touch still works. If it does, we'll continue to use it to test it. But yeah, that's my test screen. Trust me, I would mouth if it was Mason. I'm pretty sure this is my test screen. This one's trolled me a couple of times, and I keep throwing it right back in the same spot. Like, I'll grab the other one next time. Alright, so we're booting on battery power this time, which means this thing should boot without rebooting. If it don't boot without rebooting, well, something else wrong with it. Yeah, and see, the startup sound that played right there, that's the second that it rebooted last time. So we do have working touch. I'm going to move this out of view because I'm worried. I'm worried about strobe, and I really need to test this one. Let me look and see if I got a passcode. Well, I'm left with the decision here as to what to do with that strobe driver. I don't actually have a passcode for this one, so that's going to conclude my video. Man, I'd like to test that strobe driver, because you've seen there was a little bit of solder that pushed out at that outer corner, but the way my heat flowed, did it really get hot enough to melt all of the balls underneath? My nozzle's like this big, the board's like this big, so there's a pretty good chance. I really don't know that yet, so I'm going to work that out on my time. I'm going to work out how to test the strobe driver here and try to make sure that I don't need to do any additional work, because that's a component that I can replace. I don't like to. You know, it's all nasty underfilled right up there against the whole freaking world, so who wants to replace that if they don't have to? I'm going to try not to. So anyways, that is going to be it for this video. This was an iPhone 6 Plus that had a VCC main short that was actually internal inside of the Chestnut display driver. So I hope you all have successful repairs, and I really thank you for watching. I'll see you next time. Have a good day, everybody.